Okay, we're going to extend our trig functions to be able to find the trig values of any angle, not just those special angles, or not just from a point that's on the unit circle. So we're going to kind of extend this idea of the unit circle and say that we could have a circle of any radius r. It's not going to matter whether it's a unit circle or not. As long as we can think of a circle with the center at the origin, then it's going to have this equation down here of x squared plus y squared equals r squared. Okay, so we've got this equation of a circle with its center at the origin. So that's going to be one of the key formulas that we're going to use. And if we take this circle and we've got some point xy that's on that particular circle, then we can drop in the altitude here and we can form this right triangle. And then combining the idea of the circle with our SOHCAHTOA, our right triangle trigonometry, then we could say that the sine of theta, which was opposite over hypotenuse, now becomes y divided by r. The cosine, which we thought of as being adjacent over hypotenuse, well, the adjacent side is now the x value of our coordinate. And then the tangent, which was opposite over adjacent, becomes the y coordinate divided by the x coordinate. So if we know these four equations, these four formulas, the x squared plus y squared equals r squared, the y over r, x over r, and y over x, we can use these four to find the trig values of any angle. And the only thing we have to keep in mind is just making sure that our signs are correct for the quadrant that our angle ends up in. So if we take this point 3, negative 4, so we want to find the sine, cosine, and tangent of an angle theta whose terminal side passes through negative 3, 4. So I've got that kind of drawn in our diagram here. We've got the point 3, negative 4. Remember, our terminal side is the ray coming from the origin, extending out through that point. And to find its sine, cosine, and tangent, we simply need to know the x, the y, and the r, the radius of the circle that would be formed with the center at the origin and the point negative 3, 4 being on the circle. So we're going to start out here by using our x squared plus y squared equals r squared, which hopefully you noticed from the previous page is really just a version of the Pythagorean theorem. Instead of a, b, and c, we have x, y, and r. When we solve that, we get our radius, our r value, to be 5. So then when we go to find the sine of theta, sine is y over r, so that becomes 4/5. Cosine is the x over the r, which would be negative 3 divided by 5. And tangent is y divided by x, which is just negative 4 divided by 3. Okay, so simply by knowing the coordinate and the value of r, which would be the radius of a circle that that point would lie on, we can find the trig values of that particular angle. Okay, so let's look at a similar problem, but kind of a different presentation. We know the tangent of theta is negative 5/13, and we know that the cosine of theta is greater than 0. So the first thing we want to think about is which quadrant that's going to end up in. So if I think about my quadrants, I've got the tangent being negative 5/13. So the tangent is negative in the fourth and in the second, because one of the coordinates, either the x or the y, is negative. But at the same time, I need the cosine of theta to be greater than 0. I need cosine to be positive. Well, cosine is positive in the first and in the fourth, which means that the angle we are looking for is going to have to be an angle that ends up down here in the fourth quadrant. Okay. So that being said, all I need to know is I need to know what the x is, what the y is, and what the r is. Okay. Well, remember that tangent of theta is y divided by x. So I've got 5/13. It's a negative 5/13, but since I know that the angle is in the fourth quadrant, I know it's the y that has to be the negative. So I know that my y is going to be negative 5. I know that my x is going to be 13, and I need to figure out what the r value is. So I'm going to go with 13 squared plus negative 5 squared equals r squared. And we're going to solve for r. So I'm going to get the square root of 194 is equal to r. And the question is, can that be simplified at all? So we need to decide, are there any perfect squares that can be divided out of that 194? So if we go through and we think about any perfect squares that'll come out of there, it doesn't look like this is going to simplify it all. So our r is just the square root of 194, which means sine of theta is y, which is negative 5, over the square root of 194, which would be negative 5 square root of 194 divided by 194. And that is our sine of theta. So next thing we're going to talk about is reference angles. And reference angles are really a pretty simple concept. A reference angle, and we use this theta prime to denote the reference angle. Reference angle is simply nothing more than a positive acute angle, which means it's got to be less than 90, that is formed by the terminal side and the x-axis. So a reference angle is always going to be between our terminal ray and the x-axis. Okay. So if our angle is in the second quadrant, as this theta in yellow is, then our reference angle theta prime is in here between the x-axis and our terminal ray. Okay. If I were to put a ray over here in the fourth quadrant and make this my theta, then my theta prime is going to be in here between that ray and the x-axis. Okay. So the theta prime is just indicating that that is a reference angle. And if you think about the idea of coterminal angles, all the angles that are in the same location have the same sine, the same cosine, the same tangent. They might just have different measurements. That's what a reference angle does. It lets us take any angle in the plane and kind of relate it back to some positive angle in the first quadrant. And when we figure out our trig values for that angle, they're going to be the same for the theta prime, the reference angle. Examples. Okay. So I have theta is 150 degrees and we want to find its reference angle. So the first thing I do is I plot the 150. The closest x-axis to that 150 is the 180. So I'm looking at the difference between the 150 and the 180. So our theta prime, our reference angle, ends up being 30 degrees. So in the second quadrant, I just have to subtract my angle from 180, and that gives me its reference angle. What if theta is 205 degrees, 205 degrees? So where is 205? Well, 205 is going to be somewhere down in here. Okay, so there's my 205. So where is my reference angle? My reference angle is going to be this one right here, between the x-axis and the terminal side. Well, this one is past 180, so in order to get the reference angle here, I take my measurement of 205 and I subtract the 180 degrees to find the difference. So my reference angle here is 25 degrees. So if I were to look up the sine of 25 degrees, I could get the number value, and then the fact that it's in the third quadrant means that the sine is negative. Okay. How about in radians? Theta is 9 pi divided by 5. So what quadrant is 9/5 pi going to end up in? Well, here's 2 pi, okay, and here's 1 pi. Well, 9/5 is not quite 2. So our 9/5 is going to be somewhere over here. So here's our theta, which is 9 pi over 5. So our reference angle is going to lie right in this little gap here. So theta prime is going to be 2 pi minus 9/5 pi. Okay? And you always need to take the larger of the two, the x-axis or the angle I have. Take the larger of the two and then subtract, because remember, theta prime, our reference angle, always has to be positive and it always has to be acute. Well, 2 pi is the same thing as 10 pi over 5, minus 9 pi over 5 means that our reference angle theta prime is simply 1/5 pi, or pi over 5. And there's our reference. Okay, a couple more. So without using a calculator, we want to evaluate the sine of 135. So the first thing is we need to figure out which quadrant does 135 lie in. Okay. Well, 135 is less than 180, so it's going to be somewhere over here. So here's my 135. So I need to know what is theta prime. What is its reference angle? Well, theta prime would be 180 minus 135, which means my reference angle is 45 degrees. Okay. So everything about 135 comes from 45. So what is the sine of 45 degrees? Well, that's the square root of 2 divided by 2. Since we are in quadrant number 2, in the second quadrant, we know that the sine is positive. Oops, kind of running out of space there. So sine is greater than 0, which means that the sine of 135 is also positive square root of 2 divided by 2. Okay, so let's look at the next example. Cosine of negative pi over 3. So again, my first thought is to figure out which quadrant I'm in. Well, negative pi over 3, a negative angle, okay, means I'm coming down this direction here. So here's my negative pi over 3. Well, notice that this angle is in the same spot that my reference angle is supposed to be. So when I'm talking about theta prime, we just have to remember that reference angles always have to be positive acute angles, which means that theta prime is actually just positive pi over 3. So I need to be thinking, okay, what is cosine of pi over 3? And the cosine of pi over 3 is going to be 1/2. But since negative pi over 3 sits in the fourth quadrant, what is the sign of cosine in the fourth quadrant? Well, the cosine is still positive, so the cosine of negative pi over 3 is also positive 1/2. Okay? So we use the reference angle to take it back to something that we already know, and then we just put the appropriate sign on our answer depending on the quadrant that our angle is sitting in. Okay, so that'll be all for today, and we will go over some more of this in class tomorrow. So hopefully those of you who are doing the testing will be able to keep up and keep track of what's going on, because the plan is to have a quiz near the end of the week. So we will see you tomorrow.